Hi, I'm Nhan Tran from Kodo School of Mines. Today, I'll share with you the first step towards making mixed reality robot communication adaptive to the human mental workload. Imagine a scenario in which you are collaborating with a robot teammate in a search and rescue mission. If the robot senses a highly ambiguous target, it might use a complicated description, which could be confusing. Research has shown that robot use of physical static gesture, such as pointing, enables more natural and effective interaction. However, not all robots have arms. What if we pair language with visual gestures such as arrows so that targets are picked out in the human's field of view? We hypothesized that pairing language with visual gestures can simplify the robot's language. Instead of saying a complex description, the robot can just say, "I found a victim over there," and point to the hard to describe target. Additionally, our previous work suggests that visual gestures and language may be highly sensitive to the human's mental workload. If you have a hard time identifying a target, the robot might want to use only verbal language. If you're not able to hear the referring expression, the robot might want to rely on visual communication. My current work tries to answer these two overarching questions. First, how do different types of mental workload impact the effectiveness of different robot communication modalities? Second, how can a robot select the effective robot communication modality given information regarding its human teammates' level and type of mental workload? As a first step, my labmates and I designed a human subject experiment in which the participant gets to wear a Microsoft HoloLens and play a game with the robot Pepper. The participant's main task is to pick and place some virtual objects into virtual bins as suggested by the robot. To test how humans perceive different strategies, the robot occasionally interjects with a secondary task. It would use a combination of language and visual gesture to ask the participant to place a different block into a different bin. Further, we want to test how these strategies are affected by the user's mental workload. We systematically vary several elements within the primary task to manipulate the participant's mental workload.
We are still analyzing our data, but our preliminary results suggest that different communication styles were needed to enable better task performance under different types of mental workload.
Thank you for listening. To find out more, read the paper, and if you have any question or suggestion, let's chat via email or Twitter. Thank you.